Hi, welcome to part 64. We look at some more questions. Please subscribe if you have not done already. The client already has file shares. They want to move to AWS. The file shares are on Windows Server. They use SMB protocol and a self-managed on-premises Active Directory controls the access. The client wants to use Amazon FSx for Windows file server. This is something which is meant for Windows SMB protocol. Since they have mentioned SMB and Windows, so they are currently using. Now the question is a security question. They want to restrict access to Windows file server, and they have created FSx for Windows file server file system. So will you create connector to connect Active Directory and map the groups, or will we assign a restrict tag, or will we create IAM service link role to restrict the access, or join the file system to Active Directory to restrict access? So we would join the file system. So we have a file system. This is a file system. The SMB Amazon FSx for Windows file server. So this is a file system, and this has to be integrated with the existing Active Directory. So Active Directory is already there. So we would not use anything related to IAM here, and um, a restrict tag key and compliance tag key. This will not work. This is related to IAM groups. IAM groups is not. So we can restrict the access by reusing what is already there in Active Directory. So option D would be our answer. We would join the file system to Active Directory to restrict the access. So the company already has a retail website. Now they want to go global. They want people, for example, if this website is in India, they want to give access to people in America, people in UK, and so on, other countries. And what does the website use? So they are using EC2, which is a elastic compute cloud system. It is a compute solution, so you can put your application there, and it is behind uh, elastic load balancer. This is used for balancing the loads. Like you have a website today, 1000 people are concurrently accessing it. Tomorrow there can be 10,000 people concurrently accessing it, so the load increases. That load needs to be managed. So you have different kind of load balancers: application, gateway, and network load balancer. In this case, they are also making use of auto scaling group here across multiple AZs, so that the scalability can happen. If the load increases, it will automatically add more EC2 instances. They want to provide its customers with different versions of contents based on devices that the customers use to access the website. So if you are using a mobile phone, a different sort of UI and different content is visible. If you are accessing through website, a different UI and different content is visible. So what two actions we have to take here? See, one thing is sure, we'll have to make use of CloudFront, because we'll have to, whenever you go global, whether it's your website or any application, you have to use CloudFront. Even Netflix, they make use of CloudFront because they are a global service, and you can view it in different countries, so many different countries. So CloudFront would be one, and you cache multiple versions of the content. This is one correct answer. The AWS Global Accelerator, you can improve the availability, performance, and security using the global network. So primarily, you can improve the performance of your applications, and you can protect from DDoS attacks. Yes. So you can connect up to so many different regions. You can. This is for global accelerator edge locations. If you see the customer Sky, Scanner, Joy City, and etc. This is mainly for website, but in this case this will not fit the bill, because when we are going global, we will have to make use of CloudFront. So both these options would be wrong. D and E both make use of global accelerator, and then B is telling that configure the host header in NLV to forward traffic to different instances, but uh, that will not help you with different versions on the different devices. That will not help you with that. you will have to make use of lambda edge function. So it is an extension of lambda. You can deploy Python Node.js functions on CloudFront. This is especially so when we are talking about CloudFront, you should make use of lambda edge. This is a common use case. Lambda edge is to use functions to customize content. So here we have to customize, like, because mobile phone different content will be viewed, and website through the computer a different content will be viewed. So that customization of the content is possible here through lambda edge. So in this case we will mark C also. So A and C are our answers. We will use CloudFront first, and then since we are making use of CloudFront, it is imperative to make use of lambda edge. So you have an application and you're making use of, so there are two things, there are two components to be known here. You have EC2 instances which is put on one VPC, and then you have elastic cache which is on other VPC. So you basically have two VPCs, one for EC2 and one for elastic cache. What is elastic cache? It is used for real-time performance. So elastic cache, you can add this cache to on top of database and so on. It will help you with improving the performance of your application. And EC2 we already know it is a elastic compute solution. So in this case you have two VPCs. So whenever you get this scenario that the VPCs are in the same region, here you see they are in East US East region, and we have to do it most cost effective. The most cost effective for these two VPCs to talk to each other is peering connection first of all. So now peering connection, we have two options, A and C. So transit VPC automatically becomes incorrect. The transit VPCs, why do we use? It is a common strategy for connecting multiple dispersed VPCs. Okay. And remote network. So you have VPCs on AWS plus you have a remote network. You want to create a global network transit center, then you use it. In this case, we just have simple requirement. Both the VPCs are on AWS. There is no remote network to be added here. So we will make use of peering connection. So this is an example of VPC peering. It is a connection is a networking connection between two VPCs. You see here in this diagram, they have two VPCs, VPC A and VPC B. They are talking to each other through VPC peering connection. So here we see two options with VPC, transit VPC. These two are wrong, B and D are wrong. Now you have to choose between C and A. C is incorrect because the difference between C and A is almost same, but the difference here is they are trying to create a inbound rule for peering security group. We don't want to put anything for the peering security group. We want to put it for the elastic cache. See, because elastic cache wants to talk to see, EC2 instance has to talk to elastic cache. So elastic cache should allow inbound connection. So that is why A is correct in this case, because A is telling you that elastic cache inbound rule will be set and inbound connection from application security group will be allowed. So what is the application security group? From the application EC2 instances, from here it will be allowed. So this is the most apt answer. If you're not yet subscribed, this channel will help you with AWS, Azure and Google Cloud certifications. This brings us to the end of part 64. See you in the next part.